So this is a very important video where we are studying transmission as well as reception part of the cyclic codes. All the points that we have covered in the previous videos are also there in this video. So you will get a total understanding about the cyclic codes. So the problem is a binary message sequence 1001 is coded using a generator polynomial. This is generator polynomial. Assume that the code generated is a cyclic code. Determine length of coded sequence. So what is the length of coded sequence? For that, we know that generator polynomial has the degree n minus k. So n minus k is equal to 3. Its degree is 3. Degree is what? Highest power of the polynomial. So that is 3. What is k? K is number of message bits. That is 4. So k equal to 4. Now n equal to n minus 4 equal to 3. N minus 4 equal to 3. So n equal to 7. So we got the answer that the code which will be generated has number of bits 7. Now we have to find the transmitted code word. You can use the division algorithm method, but here we have to do decoding as well. So there we require syndrome. That's why we are going to solve this problem with generator matrix method, where we will get the parity check matrix also. And this is the common this is how the problem is solved. When the reception we have to detect the errors or correct the errors. So generator matrix, we already know how to form the generator matrix. Generator matrix can be formed by the generator polynomial. This is the generator polynomial x cube plus 0 x square plus x plus 1. So there is no x square term, so we have written it as 0x square. So write down all the coefficients of all the powers. So 1, then 0, then 1 and 1. So generator matrix is of dimension 4 into 7. That means 7 columns are there. So remaining 3 bits are write down as a 0. After that, take this 0 or this term here and write down all these terms ahead. For the third row, take this 0 here or term, whatever. If there is 1, you can take it as 1 here. Here there is 0, so 0, and write down all the terms ahead. Then after that, take this 0 here and write down this row ahead up to 1. That means you are doing the cyclic shifting of this 7 bits. So first cyclic shift, so 0 is here and all these comes ahead of it. That we have seen in previous videos also, but it's easy. Take 0 here and write down other terms, then 0. Cyclically you are shifting. After that, this is not in the systematic form. So for that, you should remember this. G is I K P K into N. This you need to remember, because then only you can form the standard form. So IK, that means you need here K by K identity matrix. So forming K by K identity matrix, you have to hide these 3 columns and decide about the row operations. So R1, you need R1 as 1,000. For that, if you add R1, R3 and R4, then this is a mod 2 operation where 1 plus 1 is equal to 0. So this 1 plus 1 gets cancelled out and this 1 plus 1 get cancelled out. For R2, you want 0, 1, 0, 0. For that, you can add R2 with R4. Then this 1 and 1 gets cancelled out. So like this, you have decided the row operation. For deciding the row operation, don't see on these 3 columns. After that, you have to apply these row operations on whole matrix here. So G is R1 plus R2 plus R1 R3 plus R4. So R1, you have to focus on R1, R3 and R4. and see how many ones are there. If odd ones are there, write down 1. If even ones are there, then write down 0. So 1 0 0, odd 1, so 1 0 0 0 0, 1 1 1 0, or even 1, so 0. So 1 0 1, even 1, so 0. 0 1 0, odd 1 1, 0 1 1, even 1, 0. 0 0 1, odd 1 1. R2, you have to see R2 and R4. R2 0 0 0, 1 0 1, 0 0 0, 1 1, even 1, so 0. Then 1 0, odd 1 1, 0 1, odd 1 1, 0 1, odd 1 1. After that R3 is as it is, because no need to change, because R3 is in identity form. R3's so this part is in identity form, IK 4 by 4. So this is as it is. R4 is also as it is. So this is in the standard form, IKP. Then from this you have to find the transmitted code word. For that you have to write code and message here. Code is equal to message and this generator matrix, standard form of the generator matrix. So this is code, this is generator matrix, this is message, this is generator matrix. Now what is the trick? You have to see in the message where are the ones. So 1 is in the first position, we are considering this as a first position or MSB. So 1 it at MSB, so you have to use first row of the generator matrix, and this one, so you have to use last row of the generator matrix. Then forget about this message, write down this first row of generator matrix and fourth row of generator matrix and do the mod 2 addition. Mod 2 means XOR addition. So 1 plus 0 1, that means even ones 0, odd ones 1, 1 0 0 1 1 1 1 1, even, so 0. So answer is code is equal to 1 0 0 1 1 1 0. Now you can observe that first 4 bits are message bits 1 0 0 1, and next are parity bits 1 1 0. So this is a systematic cyclic code, because first you are getting message bits and then it is appended with the parity bits. Why these parity bits are there? So if you are going to transmit this code through the channel, so noise may appear. So if noise appears, it changes 1 to 0 or 0 to 1. That's what happens with the binary thing. So for that you need to add some detection procedure or detection bits. Those bits are parity bits. Now what is next question? That they are saying that assume fourth bit in the received word is in error, work out the syndrome. So they say that this code is transmitted through the channel and this fourth bit 1 is corrupted, or this is changed to 0. Now this is this you got at the receiver side. Why? This is called received code word. This is called correct code word. This correct code is transmitted through the channel and it is changed to the Y, that is received code word. Now how to detect it? For that you have to find first the syndrome. How to find syndrome? You have to divide this Y. First you have to make the polynomial from this. You know how to form the polynomial, that we have already seen in one of the video. So how many bits are there? 7. So the first, so highest power will be 6, x raised to 6. If 7 bits are there, then highest power will be x raised to 6. So this one is coefficient is corresponding to x raised to 6. So x raised to 6. For x raised to 5 there is 0 coefficient, no need to consider. 4 no need to consider. X raised to 3 no need to consider. X square you have to consider because one coefficient is there, and x you have to consider. So yx is equal to x raised to 6 plus x square plus x. Now you have to find the syndrome. Syndrome will be this received polynomial divided by your generator polynomial. So the received polynomial yx by gx is equal to sx. Now yx is equal to x raised to 6 plus x square plus x. Gx is x cube plus x plus 1. So the first division will be 6 minus 3, that is x cube. So x cube. Now this x cube you multiply with all these terms. X raised to 3 plus 3 is 6. 3 plus 1 x raised to 4. 3x cube. Okay. Then how many similar terms are there? X6 similar, so cancelled out because it is a mod 2 operation. Then write down in the highest order or descending order. So remaining are x raised to 4, then x cube, x square and x. After that this is 4, this is 3. So 4 minus 3 is x. So division quotient will be x. This x we got from this x you have to multiply with all these terms. So x raised to 4, 3 plus 1 4, x 1 plus 1 x square plus x. Now how many similar terms are there? X raised to 4 x square and x also. Remaining is x cube only. Now x cube, 3 minus 3 is 0. So the quotient will be 1. X cube divided by x cube is 1. So 1. So multiply this 1 with all these terms. So x cube plus x plus 1. So what you got? X plus 1 only, because x cube get cancelled out. Now you need to know how many bits are there in the syndrome. So syndrome will have n minus k bits. Syndrome is like a parity. So how many parity bits are there here? A 7, 4 code has the parity bits 3. So syndrome has 3 bits. If it has 3 bits, then you know that highest power of this polynomial will be x square. But x square is not there, so write down 0. X is there 1. So syndrome is s equal to 0 1 1. So you must know how many bits are there, then only you can write down these bits. So after that you got the syndrome 0 1 1. So from generator matrix you have to form the parity check matrix. So how to form the parity check matrix? Parity check matrix has the form pt I n minus k into n. This you have to remember. H so H will have इसमें so H has the form pt I n minus k into n. This you have to by heart, like here ikp k into n. So pt means this is the p term, you have to take the transpose 1 1 0, write it as a 1 row, then 0 1 1 second row, 1 1 0 1 third row. After that I n minus k, that means I 3 by 3. So form the 3 by 3 matrix of I 1 0 0 0 1 0 0 0 1. N is 7 and k equal to 4. This so you got H matrix from the generator matrix. This you should remember. Then only you can form the parity check matrix. Also generator is IKP, k into n, and it's easy to remember also. After that, what is the role of parity check matrix? Now this is the parity check matrix. Take the transform of this transpose of this parity check matrix. That means 1 0 1 as a first row, 1 1 as a second row, 1 1 0 as a third row, 0 1 1 as a fourth row, 1 0 0 fifth, 0 1 0 sixth, and 0 0 1 seventh, 7 row or 8 row, 7 rows, because 7 rows, 1 2 3 4 5 6 7. So HT has 7 rows. Now you got HT. Now see where is your syndrome in this HT. Your syndrome is 0 1 1. So HT is in the fourth row, 0 1 1. This indicates that fourth bit of this received code word is in error. first row corresponds to MSB, then second row second bit, third bit, fourth bit, and this is LSB. So don't interchange the what we can say, that don't write it here as a LSB or here as MSB. This is for this syndrome is corresponding to the error in MSB of the received code word, and this for the LSB. Then you can sequence wise write down MSB to LSB. So fourth bit from this side is in error. So this we identified with HT that this is in error, and we know that this is in error because we have introduced error in this. So how we have introduced the error? We have changed the 0 to 1. Sorry, 1 to 0. Your correct code word is this one. We have changed 1 to 0. And in binary, what is the error? Changing change of 1 to 0 and 0 to 1 is the error. So you detected the error. After that, how to correct it? So how to correct it? It's easy. Change 0 to 1. So this is in error, but we will write as per your textbook. We will write corrected code word as y is equal to e. What is the e? Error pattern. What is error pattern? Only wherever error is there, write down 1 there and fill other with the zeros. Error pattern will be of 7 bits again. And here is the error. You can directly write down here 1 and correct it, but we will follow the textbook method. So e is with 7 bits, and wherever error is there, write down 1, other bits are 0. Then addition of y and error pattern. Other are 0, so no change. 1 plus 0 is 1. So you got the corrected code word, this one. So this is the very important topic in cyclic codes.